Okay, this is 5-2, all the inverses. For the inverses, I'm going to get an extra sheet of paper so I can write on it because this is kind of small. Which, if you feel like there's not enough room on the homework and you want to write on notebook paper, that's fine. If you need notebook paper, I have a lot. I bought a lot of this summer. So for these, I'm trying to find the inverse, and I'm going to graph the original and the inverse on the same grid. So that's where you make the table for F and F inverse. You're going to start by looking at your operations and writing a table of your operations, where you start with X, and then you follow PEMDAS to follow your order of operations. Just a reminder, PEMDAS is the parentheses, the exponent, multiplication, division, addition, and then subtraction. So over on the original, the first thing I did to X was that exponent, the square. Then I multiplied by 1/5. When you multiply by a fraction, it's the same thing as saying that you divided by the number in the denominator. So if I say I multiply by 1/5, it's the same thing as saying I divided by 5, which in these cases it's easier to say that you divided by 5. So that's the steps you took on the original. For the inverse, you start with that last step and you do the opposite operation. So the opposite of multiplying is dividing. So if you divided, the opposite would be multiply by 5. Then the opposite of square is square root. So you write that out. F inverse is, I'm going to say X, I'm going to multiply X by 5, then I'm going to take the square root of that. So the inverse of 1/5, inverse function of 1/5 times X squared is the square root of 5X. Now that I have the function and its inverse, I can graph them. So I put them both into the y equals. I can find some points. So I'm going to go with 5, 5. 0, 0, negative 5, 5. So I have negative 5, 5, 0, 0, and 5, 5. That's my parabola, that's my original. And my inverse, I'm going to do in red. So my inverse, my x and y switches. So 0, 0, 5, 5. But this time, the function kind of bows up like this. That's my square root. So another one that I was asked about was number 3. I'm following PEMDAS still, so the first thing I'm doing is that exponent. So I'm going to square. Then I multiply by a -1. Then I added 10. So when I do the inverse, I'm going to start with the last step, do the opposite. Instead of adding 10, I'm going to subtract 10. Instead of multiplying by -1, I'm going to divide by -1. The opposite of square is square root. So now when I write that, f inverse of x, I start by writing x, and then I follow my table. So it says subtract 10, divide by -1, and then take the square root. So I really don't like having a -1 in the denominator. X minus 10 divided by -1. Have a negative in the denominator. That makes that x negative. I have 1 times x, so 1 divided by -1 is -1 x, and I have a -10 divided by -1. That's plus 10. So my inverse, all cleaned up, would be the square root of -x plus 10. So again, I'll find points of those. I'm going to go to the calculator, put them both into y1 and y2. So for the original function, I have plenty of points to choose from. For the inverse, I'm kind of limited. So for the original, I'm going to use these points. For the inverse, I'm going to use these points. So I plotted the points. The blue is the original, the red is the inverse. And then 0, 10 is going to be somewhere up here. So that's my original, it's a parabola. The inverse starts over here, somewhere around 10, 0. Kind of comes up. So I'm going to do number 5. So number 5, So I'm starting where x is. The first thing I did to x was subtract 1. Then I took the square root. Then you multiply by 2/3, but it's easiest if you split it up and say that you multiplied by 2, and then that you divided by 3. And then the last thing will be to add 3. So inverse, you're going to start the last thing, do the opposite. So the opposite of add 3 is subtract 3. The opposite of divide by 3 is to multiply by 3. The opposite of multiply by 2 is divide by 2. The opposite of square root would be to square. And the opposite of add or subtract 1 would be to add 1. So our inverse is going to look rather weird, but that's okay. You start by saying x, and then our first step was to subtract 3, then to multiply by 3, then divide by 2, square, and add 1. Look at these two equations. Here the -1 was on the inside, now it's add 1 on the outside. Plus 3 was on the outside, away from everything else, now it's in the middle of everything, and it's opposite. It's -3. 2/3 is on the outside, now it's on the inside, and it's upside down, it's 3/2. So I put the original and the inverse in y1 and y2. I'm going to find some points. So now for the original, I picked 1, 3, 4, and about 4.1, 8, and about 4.8. So looks something like that for the original. The inverse I have 3, 1, and then around 5, it's up here at 10. And at 1, it's somewhere around 10. Okay, number 8 is a word problem. It tells you that you have some function where its length of time gives you 9.8 times the period divided by 2 pi squared. So it tells you, it gives you time, or it gives you the period, which is in time, and you're supposed to find length. So I write that out. So x of t, you're given time, and you're supposed to find length. So that's the original. The inverse is going to be t of x, where you're given length, and you're supposed to find the time, which is the period. So you're going to make a table. In my equation, I'm going to start with t. First thing I did to t, inside the parentheses, I'm following PEMDAS, is divide by 2 pi. Then I squared. And then I multiplied by 9.8. For t of x, I'm going to start with the last operation, do the opposite. Instead of multiplying by 9.8, I'm going to divide by 9.8. Instead of squaring, I'm going to square root. Instead of dividing by 2 pi, I'm going to multiply by 2 pi. So now it's t of x. So x is my variable. So I'm going to say x. I'm going to divide it by 9.8. Take the square root of it and multiply it by 2 pi. The next thing in the problem says, then find the period of the pendulum with the length of 5 meters. So now it tells me length, which is x, and it asks me to find the period, which is time. So I'm going to put in 5 for x. So I'm going to say 2 pi times the square root of 5 divided by 9.8. So in the calculator, I'm going to put 2 pi times square root of 5 divided by 9.8. I'm going to get it to be roughly 4.49. So over here, I'm going to say t is 4.49 seconds.